In this video, we're going to talk about how to use the two compound interest formulas that you see on the screen. As you look at these two compound interest formulas, you will notice that there are certainly multiple things that they have in common. Specifically, A, P, R, and T. So let's talk about those four variables first, since those are in common between both of these formulas. A is going to be your final amount. So, if we're talking about compound interest, you're usually talking about like a loan or, investing money like a savings account or retirement account, something like that. So it's however long you have the account, whether it's you owing money or gaining money, what that final amount is going to be. That's A. P is the initial amount, the beginning amount. P stands for principal, not like your principal at a school or something, but it is a separate word, principal, meaning, like it says here, the starting amount, what you began your account with, whether it's the initial amount that you took out for a loan, or whether it's the amount of money that you put in to start your investing account. It's the beginning amount. R represents your rate. Generally, it's going to be given to you as a percentage, but you do not ever want to plug a percentage into a formula. You always want to take a percent and change it into decimal form before you plug it into your formula. So remember, the way that you change a percent to a decimal is divide it by 100. The word percent is literally telling you to divide by 100. Per generally means to divide in math, and cent is a prefix that represents 100. So the word percent is literally telling you divide by 100. T represents the amount of time that this account is going to be open, whether it's the amount of time you're investing or the amount of time you have to pay back the loan. It's the total time that you're keeping this account open. You should always represent T in years. Now, generally, you're going to be given a period of time in years because that's how most things are done, especially like loans and that sort of thing. But if you're ever talking about it, say you're given a problem where you're talking about investing for only 9 months. Well, you would not plug in 9 for T. You would want to do it in terms of years. So since there's 12 months in a year, you would make it 9 over 12, or 9 out of 12, which would then reduce to 3/4. And that would be what you'd plug in for T in that scenario. Generally, like I said, T is going to be given to you in years, but if it's ever given in something other than years, you always want to write it in terms of years. Now, there is one difference between these two formulas, and that would be N. You'll notice in the second formula on the right, there is no N for that. N represents the number of compounding periods per year, meaning if you are told that you are compounding annually, that would be once a year. If you're told that you're compounding monthly, that would be 12 times a year. So N would be 1 or 12 respectively. The reason why our formula on the right does not have an N is because we only use our formula on the right for when we compound continuously. If you are told that you are compounding continuously, then you use the equation, the formula on the right, the A equals P times E to the RT power. Do remember that E is not a variable. E, much like pi, represents its own number. It's an irrational number, but it roughly comes out to 2.718 if you want to approximate. But just like pi, it runs on forever, and so E is meant to represent that number. Most likely on whatever calculator you use, you probably have an E to the X button. So don't think you're plugging something in for E. If you are compounding any other way than continuously, meaning if it says literally anything besides compounding continuously, you will use the first formula. Alright? So let's look at an example here. Let's say Bobby and Sally, random names obviously, Bobby and Sally invest $5,000 in an account that pays 4% annual interest. How much will there be in the account after 10 years if the interest is compounded? And then we are given 4 separate possibilities: compounding annually, semi-annually, quarterly, or monthly. Well, to begin with, I'm looking at how it's compounding. I don't see continuously listed anywhere in that question, so the fact that I do not see anything about compounding continuously tells me that we must be using our first formula of A equals P times 1 plus R over N to the NT power. That must mean that of the 5 variables A, P, R, N, and T, I must be able to find values for 4 of them in that word problem, because I can only solve for one variable at a time, so if I'm supposed to use that to solve anything, I must be able to find values for 4 of them. It says that they invested $5,000. Doesn't say they pulled $5,000 out or that's what they had at the end. It says they're starting the account with $5,000. So that would be our principal, our initial amount. P is equal to $5,000. Then we're told that it pays 4% annual interest. Well, the percent is pretty much always going to be the rate. It is always going to be the rate. But we said we don't want to represent R as a percentage. We want to change that to a decimal. So we take 4% and divide that by 100, because again, percent literally means divide by 100. And that will be our R value, 0.04. T, I'm going to skip N because T is the next thing that the problem gives us. T is going to be 10 years, right? Because it asks how much there will be in the account after 10 years has passed. So that would be the total amount of time that that account is meant to be open. So T would be 10, because 10 was already given to us in terms of years. We are given an N value here, because we're told how it's compounding. But understand, there's 4 separate N values because we're doing this problem. This problem is asking us 4 separate questions. So N is going to equal 4 different numbers depending on which one we want to look at. If it's compounding annually, annually would mean once per year. If it's compounding semi-annually, it can also be referred to as biannually sometimes. Semi-annually would mean twice in a year. If it's compounding quarterly, quarterly refers to 4 times a year. And monthly, well, there's 12 months in a year, so that would be 12 times a year. So we've got 4 separate problems we can answer here. We'll start with doing it annually, so when N is 1. If I fill out the formula, I would have $5,000, 5,000, times 1 plus our rate of 0.04 divided by our N value of 1 this time to the power of, again, our N value of 1 for this time times our T of 10. Now, like I said, recognize much of that is going to be exactly the same. Really, the only thing that is special is our N value. That will be different each time we do this. Everything else is going to look exactly the same each time. So you can just plug this into your calculator. I imagine your teacher will allow you to just plug this into your calculator. We could go through technically and solve this out by hand, but you definitely can just plug it into your calculator. Make sure you are careful when you plug this in. You can plug it in all at once, but you could also take it in steps to make sure you aren't messing anything up. It's kind of up to you. If you plug it in correctly, you should end up with $7,401.22, roughly. I am rounding a little bit there, but we are talking about money, so it probably makes sense to round to the nearest cent, nearest penny. If you got that correct, then you probably shouldn't have too much problem with the other 3. Because if that's for annually, then if we do one for semi-annually, almost everything is going to look exactly the same. It's still 5,000 times 1 plus 0.04. The only difference is now it's going to be an N value of 2, because semi-annually means twice in a year. And so that's going to be the only difference. Everything else is the same, and you just need to plug all of that into your calculator and see what you get for that. I will, if I were you, I would just pause this video, because I'm going to write the rest of these out. So I would just go ahead and pause the video and run the rest of these 4. Actually, I'll go ahead and write out the other 4 so that you can see what those will look like without putting the actual answers, and then you can pause the video to check yourself. So if you're doing quarterly, then you would want to divide by 4 for your end value. And if you're doing quarterly, your end value should be 4 because quarterly would be 4 times a year. So that would be your setup for your quarterly one. And then last but not least, if you are looking to figure out how much you would gain monthly, well, there's 12 months in a year, so you would be dividing by 12 would be the idea here. So go ahead and pause this video and plug all those in, and then you can check back to see if you get it right or not. So here's what you should have gotten for plugging each of these into your calculator. A couple things I'd like to point out here. You certainly just take a look at the difference between what you got whenever we were compounding annually compared to what you got whenever we were compounding monthly. Notice that's a difference of $50-some there. Right, that is a legitimate difference. The only thing that changed was how many times we compounded each year. Right? Each of these was still at 4% interest. We were still talking about only investing for 10 years. So you can see how that can be a difference. I know $50 maybe doesn't seem like a huge amount, but that's only going to get bigger the more years we're talking about, and 10 years is kind of really a short time to be investing, really. So that's only going to be bigger, a larger difference as we continue investing further and further years out. And the same thing happens with loans, right? If you take out loans, the longer those loans are for, or the higher amount those loans start for, if you took out more than $5,000, then the number of times they're compounding each year is going to drastically, or at least somewhat, change how much money you have there. Maybe something to keep in mind for a future where you may be taking out loans for cars or homes or college or things like that. It's an important thing to know whenever it's compounding, or how many times it's compounding each year. I want to do one more example with you guys, just because we haven't used that second formula yet, so let's talk about one where we need to use the second formula. So Billy and Sue invest $12,600 in an account that earns 3.2% annual interest, and most importantly, we are told it is compounding continuously. And then it asks the value of the account after 12 years. Because it says compounding continuously, that means we are going to be using the second formula of A equals P times E to the RT. Meaning, we only need 3 values out of this equation to be able to solve it out. So we are not given a final amount, but we are given an initial amount of $12,600 that we're told they're investing. Then, we are also told a rate of 3.2%, but again, we're not going to actually use 3.2%, we're going to divide that by 100 to give us 0.032. And then, finally, T, our time in years, it asks for the value after 12 years. Again, it has to be in years, but 12 is in a year form. So we're ready to plug in then to our calculator. Remember again, E is actually a button on your calculator. E is not a variable. It represents its own number. It's the natural number. So you should have an E to the X button on your calculator that you can type in. Make sure that you are making it clear that 0.032 and 12 are both up in the exponent. If you type all of that in correctly, then you should get $18,498.63, which, if you then rounded to the nearest dollar, like the question asks you to, would be $18,499 if you're rounding up. However, you could make the argument that if you're investing, whoever you're investing with is not going to want to give you more money than you actually earned. So you could also argue that really, even though it's a 0.6, you would need to round down to 18,498. Kind of depends on how theoretical versus realistic you'd want to be for this question, and you'd probably need to talk to your teacher on what they're looking for in that scenario.